Students, today we are going to discuss plus 2 oxidation state and the lower oxidation states of chromium. Now, plus 2 oxidation state is seen in the chromous compounds of the chromium. Compounds are called chromous compounds, and these compounds are ionic in nature and they have the ion Cr2 plus, and this ion, which is sky blue colored, this gets oxidized to the Cr3 plus, that is the chromic ion, and chromium second compounds can be easily oxidized in the air to the chromic compounds or the plus 3 oxidation state compounds. And now let's discuss the chromium plus 2 compounds. For example, the plus 2 compound, the most common plus 2 compound of chromium is the hydrated acetate of chromium. Now this is your hydrated acetate of chromium. This is the most common example of the plus 2 oxidation state of the chromium. Now this compound is the red colored crystal compound, and when we discuss the structure of this compound, it is a dimeric bridged structure. Two chromium atoms are linked to each other and the structure is something like this. Here is water molecule, here is another water molecule, and so this is the structure of the hydrated acetate of chromium. Now in this structure, what you are seeing is the two chromium atoms, they are attached to one another. It is a dimeric bridged structure, and here every Cr2 plus. Chromium atom is in the state of Cr2 plus, that is the chromous ion. And here every chromous ion is surrounded by a sort of distorted octahedron. Both of these are surrounded by a distorted octahedron, and this octahedron has been made by 4 oxygen atoms of the 4 acetate groups, and 1 oxygen atom is from the water molecule, and the other side is a chromium, or we can say chromium in the chromous ion. The 4 acetate groups are like the bridge between the two Cr2 plus ions. These are like the bridge between the two Cr2 plus ions, and this distance which is between the two chromium atoms, it's very short, it's just 2.36 angstrom, and that is, here is a metal bond, and Cr2 plus has the 4d4 configuration, or we can say the 4 unpaired electron. Every Cr2 plus has the 4 unpaired electrons, that is, here in total we have the 8 electrons with these 2 chromous ions. And so as far as the magnetic properties are concerned, it is just assumed that since they have 4 unpaired electrons, so they should be paramagnetic, but the compound is diamagnetic in nature, and the distance between two chromium is also very short, that is 2.36 angstrom. So from these two we came to the conclusion that the 4 unpaired electrons from the 2 chromium atoms, they have taken part in forming these 4 bonds, these 4 metal bonds, these 4 chromium bonds, and so all the 4 unpaired electrons has been used up in making these 4 bonds, or the quadruple bond. It's called the quadruple bond. Quadruple means which is 4 bond. Quadruple bond means 4 bonds. And for these quadruple bonds, one bond will be the sigma bond. One will be sigma bond, and 2 will be the pi bonds, and 1 will be the delta bond. So these are the 4 bonds, and the structure is like this. These chromiums are in the D4 configuration, and 4 unpaired electrons are used up in making the quadruple bond. 4 electrons from both the chromium, that is in total 8 electrons has been used up, therefore it will be a diamagnetic compound. So this was for the +2 oxidation state. Besides this, chromium also shows the lower oxidation states like +1 oxidation state. This will be shown in the dipyridal complexes, and we have already discussed that the transition metals form 0 oxidation state with the carbonyls nitrosyls. So 0 oxidation state will be seen in the case of the chromium carbonyl and in the carbonyl ions, etc. And the carbonyl anions are also seen in case of the minus one oxidation state which is seen in the Na2Cr2CO10, and -2 oxidation state will be shown in the case of Na2Cr CO6. So these are the lower oxidations which the chromium can also show, and this is all about the chromium. And now in the next video we are going to discuss the manganese.